Hey guys, welcome to day 15 of Codeforces Every Day until GM. So after yesterday's contest, we are up to 868 rating, which is about 2/3 of the way out of this gray area. Hopefully we can get out of it soon. But I guess today we're gonna be trying to finish off problem D from the contest yesterday. I have gotten some insight from some buddies of mine, and hopefully we're able to solve it today. I'll get rid of this TLE error, and then we'll do some problems from the training sheet. We'll probably do like a question or two of A, and then move on to B, but we'll see how we're feeling. All right, without further ado, let's jump straight into the problems. So, okay, about the insight. So we created this like simulated approach last time, right? But the problem is it fails this worst case scenario of like if it just continually updates, which has a worst case of O and M. Like our code best case is O n plus M, or n plus 3, n plus M. But we want this like throughout our entire code, not just best case, right? So here's the problem. It's this line here. This array copy operation is actually O to n time. So yeah, we can just comment that out and start reworking our code from there, right? So advice one was like, you can't just simulate a lot of these kinds of problems. It's just going to be way too slow, and that kind of defeats the purpose of like using your brain or using a data structure to make your code faster, right? Now, this is a bad habit of mine. I always try to simulate it first, but it's never going to be the best approach, right? And it works for like 800 rated like implementation questions, but as you get higher, like you're going to see those less and less, right? So he recommended think how you can maintain the resets without doing the whole array, and then all you need is the final values. And so I asked maybe there's a way to check the last reset, then only do math from there. And then advice from buddy number 2 said instead of storing, well, he actually gave 2 possible solutions here, but yeah, let's read both of them. Instead of storing random values, just store the change, and then you can make it a new array whenever change I plus value is greater than h. And Java does this in O of 1, but since Python does it in O of n, this might not be a valid solution for me. And then you would just initialize the new arrays to 0. Right? You would just drop the old array and create a new one in a faster language. But he also gave this idea here, which is he basically said, Loki, you could also lazily reset, like only reset the value the next time it is touched. So you basically attach a flag to every RAM piece. And then I was thinking about this actually, and I kind of want to try this first because I think it's actually closest to what I have so far. But basically, we don't update until we need to update the RAM, right? So yeah, I might try this one. But I was also given like this advice from a third buddy this morning, one of the viewers of the channel. He left a comment before. So shout out to Mr. Oh, I probably shouldn't open my profile on stream because it's going to leak my email, but Codeforces profile friends Mr. Dynamic JL here gave this advice this morning. He said his solution was to maintain a version maintain the version an element is without resetting the entire array. And then he said he basically talked about the time complexity a little bit. If you reset like worst case, like just over and over and over again, then the overall time complexity will be just NM, like I showed earlier, which is pretty bad considering most n squared solutions probably won't pass. Now, okay, with that out of the way, let's get to coding. Close out of this and yeah, okay. So attaching a flag, like this is interesting because yeah, we don't actually need to update our array until we like need to, right? We don't need to reset our array until we need to use it the next time. So what we can do is let me think. So we take an input and then we create a copier. I still think this is necessary because we need a way to like reset values, but we don't want to use a.copy in the loop ever because it will fail a worst case. So what we can do is we can track like a last updated variable. Set it to, okay, it can be 0, so it can never be negative, right? We can set it to -1, like -1 times n. So this will create an array of -1s with the length of like how long R and A is. Right, and then we can track a like when did the last reset happen? Last reset. And set it to -1 by default. And then we can have a like counter variable. And for I in range, blah, 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 pretty standard. And then, okay, before we do like the addition here, we can like do, we have to check, wait, if we, before the addition, we should check if it's reset, or if we need to before the addition, yeah, before the addition, we should check if we need to reset it. So if last update B, because B is the index, C is the amount we add by, is last update B. A last update is an array of we're tracking the time where the index was last modified. So if the time this index was last modified was before the last reset, then we should reset it. So if it's less than or equal to last reset, we should reset it. So RB equals R, or equals A, B. Now, okay, wait, does this hold true for the other RAM values? Um, Let me think. So if then the version of an element is without resetting the entire array, right. I think this works because we only reset it when we need to use it. And then I guess we can, if we never need to use it again, we can just check at the end with our print loop. Right. I think that's valid. I don't think we can just print like this. We're gonna have to have one more loop that has a check in there, but it will be outside of the M loop, so it shouldn't be O of NM, right? So when we need to use that array, if its last update was before or equal to the last reset, then we reset it. We increment, apply the increment, and then we update our last update to last update B to counter. We also need an increment counter in here, so like maybe like here. Counter plus equals 1. And then I mean, do I even need this counter variable? I have I. We might not need this counter variable. Track this. So I think we can just use I here. Equals I. Sorry about the coughs, guys. The sickness is mostly gone. Just have a little bit of cough now and then. Like sore throat's gone down a lot. Fever's completely gone. I had a little bit of rashing, which was kind of crazy, but it's going down. So yeah, just a little bit of coughing. Hopefully it's completely gone by like tomorrow's video. But yeah, sorry about that. Okay. Last update equals I. And then if our value is greater than h, so we can keep this, we just get rid of this, then we set our last reset equal to time, equal to our time, which is I, our counter. And then this should handle all of the like reset logic. Right, and then outside of this loop, we can do another for loop where we can handle the rest of the resets. Let me think. To print equals this for I in range n. Now if I was updated after the last reset, then R is valid. Otherwise, we need to reset it. So if last update I is greater than last reset, then it's valid. So to print dot append I R I. Else we need to reset it to print dot append. And this is cool. Like instead of like doing an actual reset, we can just append AI, which is our original array, and then R is our modified array. Right. And then we can just print to print. So we create a copy. Create a last updated array and a last reset checker. And for I in range m, take an input, normalize the index to 0, check our last updated time for this index, and if that's less than or equal to our last reset time, then our previous updates were invalid and we should reset it. We increment, and then we update our last update time to current time. If our updated value is greater than our max RAM, then we need to reset. So set our last reset time to current time. And then once you do this all the time, like until M, then we can check. If our last update is greater than our last reset, print, we'll append then it's valid, and we append RI to our array, else we append the reset value to our array, right? Wait, does this handle? Let me see. Right, this should work because we reset in here as well. This is the most confusing part of it, I think. Just double check if this works. Is the logic here correct? If last update is greater than last reset, is there any cases where it's like we trigger an else, but then don't trigger an if? Nah, fuck it, just like run it, see what it gives you. Zero, 1, 1, 1. 1, 2, 4. Okay, it gives me the right answers. The question is it fast enough? Okay, this takes O of M. This takes O of N. Best case. So this should be fast enough. It's like best case O of N plus M now, and worst case O of N plus M. So okay, just double check this. If last update is greater than last reset, then we want to keep it. It should work. It should work. Browse. Programming. I need to clear out my folders sometime soon. Python. I keep forgetting this is in my Python folder. Okay. Out of memory error. Like, this low-key is a difficult question. Like, it'd be hard for me to... Like, I could see that, like, I was getting bottlenecked here. But it'd be hard for me to, like, come up with one of these, like, solutions on my own. Like, test case 4 is just gotta be a worst case where, like, you reset every single time or something. There we go. Okay, have I bookmarked that problem? Yeah. Like, I want to see if I can like figure out the solution on my own later down the line. I might do like a 1 month, like either like a review day or something. Like, okay, let me open up my Codeforces profile. Just see how many review problems I have. Submissions, favorites. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 review problems. I might do like a 1 month special video or something where I just do like an extra long Codeforces day whenever I have time for that. And we'll have like a review section of it. And maybe, no promises, but like a 12-hour Codeforces. Maybe I'll stream it. Maybe I'll do 24 hours, 12 hours. No promises, but I'm definitely thinking of something along those lines. But, okay. Let's keep working. Let's do next problem on this list. Codeforce is quite slow this morning. Oh, I did this one last time. This one? Guess I forgot to mark it. Yeah. Did I do this on video? I don't even remember. Those are the birds and the wires. How hard was this problem? The one submission one? Oh, I did this like right before the contest. No wonder. I kept running into edge cases. It wasn't too difficult though. I don't think so. Maybe I'll give it a 1.3 for edge cases. Implementation math. There we go. Do juicer. Juicier. And then we'll do like bear finding next. Juicer. Okay. 709 a juicer.py. Rating 900. Okay. Make fresh orange juice in oranges sizes A1, A2 to AN. We'll put them in a juicer in fixed order. Orange size A1, orange size A2. So on to be put in the juicer. The orange must have size not exceeding B. So if it's an orange is strictly greater, he throws it away and continues. Wait, what? In fixed order. It cannot exceed size B, so if it's greater than B, he throws it away. Special section to collect waste. It overflows if Squeeze the orange total size greater than D. When it happens, empties the waste. How many times empty the waste? Okay. 3 integers, NBD. Equals int input dot split and then the number of oranges in max size of the orange that fits is B, and then D is wait 3 integers in B and D. The number of oranges in the max size of the orange that fits in the juicer, B, and the value D, which determines when the waste should be emptied. Okay. Puts A1 in, puts A2 in. He finds one that exceeds B, so he throws it away. As soon as D number of times empty the waste. What? Second line contains n integers. Oh, so it's an array. Equals I have so many things open. Keep this open. Okay. Number of oranges. Size that doesn't fit. Garbage. Squeeze the juice in empty. For this one, you will just squeeze. And just like print the number of times we'll have to empty. Orange won't fit, so no juice at all. Collect waste. Wait, so is it the waste here is 11, so he empties the waste? He'll have no. What does he do with it? With larger ones, he doesn't throw them into the waste, right? Let's see, for this sample, there's 3 of them. All of them are under, so 12, 19. Empty the waste once. Greater. So he just throws it out. Okay. Pretty easy, right? For in range in. Here's what I can do for I in A. You can set a variable waste to 0, and we can do empty count equals 0. For I in range I, if I is less than, or if I is greater than B strictly greater than B. So it can be equal to B, but it can't be larger to B. So if I is greater than B, then we just continue. Else, oops, what's the, I forgot. Yes, there we go. Else waste or can the waste overflow? Else waste plus equals I. If waste greater than or equal to D, empty count plus equals 1. Print empty count. I feel like this question was worded pretty badly. I don't like this one at all. Like, I think this code will work for all these cases, but there's like specific cases that I'm not sure of. Oh, 2. That's not right. Why does it do 2? I don't reset anything. I need a reset. And then waste equals 0. Okay. 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 Oh, wait. This is not right. The waste is 1. So what's happening here? If it's greater than 1, we don't use it. So there's like this easy, there's an easy explanation, which is like I'm supposed to just do this, but it says strictly greater, not exceeding B, which means it could be B, but not greater than B, right? If that's the case, then the wording of this question is really bad. But that's the obvious like answer, right? You get no juice because you just don't use it, and then you don't use it, you don't have to throw out waste at all. But if you do use it, then you will have waste and you will throw it out because that happens no matter what. Right? So then it would be 1. Do you only throw it out when it overflows or if it equals? Strictly greater. So it can equal, and then you don't empty? Is that what you're saying? Strictly greater. It's a strictly. Which means it can be equal. At least that's how I'm interpreting. Maybe they're right. You know? I shouldn't assume that the question is poorly worded. I should assume that my reading comprehension is bad. Okay, there we go. Just follow what the question says. And come on. You got it? There we go. Now, let me mark it. Juicer 1, was it hard? No. By yourself? Yes. What tags did this have? Just implementation. B. Bear and finding criminals, 1,000 rated. Still pretty low. How long has the recording been? 44 minutes? 41 minutes, actually. Okay. 680 B. Bear and finding criminals. Finding criminals. Up high. Rating 1,000. Okay. What does constructive algorithms even mean? But let's do this. In cities in Bearland, 1 through n, cities are arranged in one long row. Distances between cities I and j is equal to absolute value I minus j. Makes sense. The Mac, he's back. The bear. He lives in a city A. His job is to catch criminals. Hard because he doesn't know which cities criminals are. Although he knows there's at most one in each city. And use BCD for every distance from a city A. Out of that, Lamac can catch a criminal in each city, for which he is sure that there must be a criminal. You know in which cities criminals are. Count the number of criminals Lamac will catch after he uses BCD. First line of input contains 2 integers, n and a, the number of cities, and the index of the city where Lamac lives. Second line contains integers t1, t2, all the way to tn. There are ti criminals in the ith city. Print out the number of criminals Lamac will catch. I don't get it. What? So, he lives in city A, jobs to catch criminals, hard because he doesn't know where they are, uses detector. How many criminals there are for every distance from a city. After that, Lamac can catch a criminal in each city for which he is sure that there must be a criminal. You know in which cities a criminal are, count the number. Okay, whatever. First line, 2 integers, and m. Okay. Then what? In the first sample, there are 6 cities that Lamech lives in. The third one, blue arrow. What is M? Or N and A. It's not M. Second, T. Why? What's this convention? They always use A for array. A is the number of cities and the index of city where Lamech lives. Okay, so number of cities index where Lamech lives. So lives here. Alright, these are the cities that contain a criminal. What does the BCD do? For every distance from a city, A. It'll tell you how many criminals there are for. So if he's here, the distance is 1. He's here, it'll tell him 0, right? There's a criminal at distance 0 from a third city. So he's sure to know. It's a criminal at distance 1, so he doesn't know. There's 2 criminals at distance 2. That's how this works. Second sample. There's 1 criminal at distance 2. Okay. This is a cool problem. For I in range. What range? In. It's the max of n minus a. So 6 minus 3. Do minus 1. Or a. Right. Wait, is it minus 1? Wait, if it's 3, let's run 1 time, 2 times. So I don't think we need minus 1. 6 minus 3 is 3, so run 1 time, 2 time, 3 time, 4. Oh, wait, so maybe we do need minus 1. So that, let's say we didn't have these 2. We'd run 1 time, 2 time, 3 time. 3. 1 time, 2 time, 3 time. Yeah. And then so 1 criminal. So what cases can we get? 1 criminal? Okay. Let's go up here. Case 1. 0 criminal. Case 2. 1 criminal. Case 3. 2 criminal. Case 3 is the easiest. If it's 2 criminal, arrest both. Arrests. If it's 0 criminal, arrest none. So the hardest part about this problem is this 1 criminal case. If I minus j abs I minus j. Well, it's not j, it's a. It's if I minus a equals 0, rest 1. If so this is the case where it's in his city. Now, if 1 city, arrest 1. If 2 city, arrest 0. So this is all the cases. Now the hardest part left is this. How to determine 1 city or 2 cities. Now if we're this is giving me war strategy vibes. This is A, and then this is I would always be going for the longer side. This is I max. This would be N. I equals N. Okay, wait, let's just code in these cases we know. If is 0 criminal. Wait, how do I No, it's 0 criminals. Alright, how do I get this? If I minus j. Wait, I'm here. If abs I minus a equals 0, arrest 1, arrest oh, yeah, 1 criminal. Wait, what? Abs I minus a. If sum abs I minus a plus wait. From here, I'm at a. Abs I minus a is here. That's the distance. The distance is, hold on, 111011. 111010. We are stupid arrow. We're here, and when I0 I minus a equals 3. What is distance between cities, I and j? I is 1. It's 2. Wait, this isn't right. Hold up. I think I'm going about this the wrong way. For I in range n. Well, actually, am I? We're looking at the distance between. We have to check both these at the same time. It's 1. A check left and right. So it's a minus. So this position here is a minus I, where I equals 1. This position here is a plus I. So city count of 0 if a minus I is equal to, or if a minus I exists, is 3, 1, 2. 2 minus 3 equals 1. If a is greater than 0, so if it's equal to 0, then this city doesn't exist. If a minus I is equal to 0, then city count plus equals 1. If a plus I is less than 1, 2, 3. So if a is 3, and here, n equals 6. A is 3, 3 plus 3 is 6, n plus 1. Then city count plus equals 1. Okay. I guess we can check criminal count in here as well. It means this exists. Criminal count plus equals t a minus I, a plus I, if criminal count is equal to 0, continue. Now if criminal count equal to 1, we don't even need a go 0 then. Else, well, if we'll count to if criminal count equals to 2, it's 1, arrest plus equals 2. If a minus if I equals 0, arrests plus equals 1, elif city count equals 1, arrests plus equals 1, elif something like this. Just in case. I don't know if I need this, but it might create some edge cases that I don't really want to deal with. Else is city count. City count equals 2. Arrests. And then do nothing. Print arrests. What the? Okay, something's wrong here. Okay, it's because we're not tracking the initial. Alright, I'm back. Else if I would check criminal count if T if A if T T TI criminal count equals 1, else criminal count equals 0. Well, it's just I don't need this else. Three. Okay. Missing one. So we start at position 2 here. 0. It's a one city. This is a one city situation. One city, one criminal. Criminal count is 1. It's this case. It doesn't go in here. Why? What's happening here? Int arrests line 4. Huh? There we go. Don't know what happened there. Two. So we're here at position 2. 5. Minus 2. Minus 1 is 2. 1, 2. Well, I want 3 hops. 1. I'm at position 3. 1, 2. Okay, I want 1, 2, 3. 1, 2, 3, 4, which is 6 minus 3. 6 minus 3 is 3. Wait, this is wrong. This logic here is wrong. Because it's doing 1, 2. So it's checking these, which is not right. It should be max n minus a. So n is 5 minus a is 3. 1, 2, 3, 4. 1, 2, 3, 4. So it should be plus 1 or 3. 1, 2, 3, 2. 1, 2. Yeah, okay. So we still got 0. So round 0, let's print out criminal count and city count. Zero, zero. Okay. Nope, so we go in here. That makes sense. So city count is 2. Okay. About round 3. Why don't we go to round 3? I don't understand. Rounds supposed to go up to 4 rounds. Zero, 1, 2. That's 3 rounds. Plus 1. Save. Okay, so round 1, I'm getting 1 criminal, 2. Okay, round 0, that's checking my city. Round 1, I'm getting 1 criminal, 2 cities. How? One criminal, 2 cities is a pass, but I shouldn't even be getting that at all. Round 2 is getting 0 criminals, 1 city. That's not right. Hey, here. A is 2, minus 1 is 3. So I guess we need a minus 1 each time we talk about A, huh? I of A to A minus equals 1. 0, 1, 2, 3, 4. Now get 5 minus 1 is 4. So we don't need this anymore. Or get A plus 1. Right. Jover. A minus I greater than or equal to 0. Five less than or equal to n minus 1. Three, 1. Okay, there we go. Dude, the way that Codeforces like indexes start at 1 is so trippy for me. Takes so long to debug. But I think I got it now. Let me just remove all these miscellaneous print statements. Debug statements. Three, 1. Wrong answer, test 7. Output 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Okay, here. Okay, so zero. This is a pass 2 city, 1 criminal, which is a pass. 2 city, 1 criminal. Wait, hold on. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Pass 2 city, 1 criminal, 2 city, 1 criminal, 0 criminal. 1 city, 1 criminal, 1 city, 1 criminal, 1 city, 1 criminal. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why am I getting 11? Okay, it's TI T0. T0 is here. TA. I should be doing TA. If TA is equal to 1. Okay, there we go. There we go. Let's take a look at the editorial. The map can't catch if there are only 2 cities the same distance. Are both in range if only one. This editorial sucks. It just has 2 codes. Okay, well yeah. I mean, I kind of just like accounted for all the cases, but thanks for watching, guys. If y'all enjoyed this video, make sure to like and subscribe. I guess we can fill out this thing. 1, problem difficulty. It was not difficult. It was pretty easy figuring out what I needed to do. It just took me a little while to do it and then debug it. So I'll give it a 1.5, similar to this one. Yeah, I would say it was similar to Patia and Countryside. Yeah, it's nothing I need to review. If there was a contest, I would be able to, like, it may take me a while, but I would be able to figure it out on my own, so I'll give it a similar difficulty. Yes, and constructive algo. I still don't know what that means. Constructive algo and implementation. There we go. All right. Yeah. Like and subscribe. I'll see y'all guys tomorrow. Bye.